Hello! We're going to take a deeper dive into the materials that make up those components and why specific materials are chosen for each part of the wind turbine. Understanding material selection is critical for both the performance of the turbine and its sustainability, especially in the context of circularity. Each component of a wind turbine faces unique technical challenges, which directly influence the choice of materials used. We covered the main components in the previous video: the rotor blades, nacelle, gearbox, generator, tower, and various other systems. The materials used in each component must meet specific performance requirements, including strength, durability, weight, and resistance to the elements. Let's start with the wind turbine blades. These blades are designed to capture the kinetic energy from the wind and convert it into mechanical energy. To perform this task effectively, rotor blades need to be lightweight, strong, and durable. The blades need to withstand high wind speeds, UV radiation, and the forces of the wind, so the materials used must resist cracking or breaking under repeated stress conditions. Traditionally, the structural materials used in a blade include fiber-reinforced composites, an adhesive, and core materials. We then use a coating on the blades to protect the composites from, for instance, rain and UV radiation. Composites are materials that consist of fibers, for strength and stiffness, and a polymer matrix, typically epoxy for load transfer between the fibers. The composite material have a high strength to weight ratio, can withstand high and a lot of fatigue loads, and have good durability in harsh weather conditions. Mainly glass fibers are used in the blades. And with the push for longer blades, we added carbon fibers to the main structural element to increase stiffness. These composite materials also present some challenges in terms of circularity. While it is durable and long-lasting, the two materials need to be well adhered to each other during use for optimal performance. Therefore, they're difficult to recycle, as we can't separate the fibers and the resin from each other without a lot of energy input. At the moment, a lot of research is performed on what we can do with these blades at the end of their lifetime, and how we can improve the circularity of the blades. To address this, researchers are exploring alternative materials, such as using different resin systems that are more easily recycled. Another area of interest is natural fibers. Research is exploring the possibility of using natural materials such as hemp, flax, or jute for rotor blades. These materials have the potential to reduce the environmental impact of the wind turbine, as they capture CO2 during their growth and can be recycled or biodegraded at the end of their life. Also, alternatives for the core materials are being looked into. Recycled foam materials are already adopted. Using these materials poses some challenges as well. For instance, how to ensure the same reliability and mechanical performance of the blades. The nacelle, which houses critical components like the gearbox and generator, also faces specific material requirements. They are designed to withstand extreme weather conditions and are typically made of a mix of mostly fiberglass composite materials and steel. Composite materials are used to keep the mass of the nacelle down, given their lightweight structural performance, and to protect the components inside the nacelle from the elements. Steel is used in a supporting structure. Its strength and durability make it ideal for withstanding the large forces exerted on the turbine by the rotating blades and supporting the mechanical components inside. The gearbox and generator, both of which are housed within the nacelle, require specialized materials to ensure smooth operation. Gearboxes, for example, are often made from high-strength steel alloys that are designed to withstand friction and wear. The use of durable materials is essential to prevent failures and extend the operational life of the turbine. To circumvent these typical failures, also direct drive generators are used, for which very powerful permanent magnets are needed. These typically contain rare earth metals. There are three types of magnets used, mostly neodymium magnets. For smaller turbines, ferrite magnets might work as well, as are less powerful, And in case of extreme environments, an alternative could be samarium cobalt magnets. As we move towards more sustainable practices, there's an increasing need to consider the recyclability of these components. Steel is highly recyclable, which is a major advantage. Still, the focus is on reducing the use of rare earth metals in the generators and finding ways to replace these with more abundant and less environmentally problematic materials. The tower is another crucial element of the wind turbine that must be strong and durable. Since it supports the weight of the nacelle and the rotor blade, it is built to withstand significant mechanical forces. Towers are generally constructed from steel or reinforced concrete, with steel being the most common material. Steel is chosen for its high strength, ability to resist corrosion, and ease of fabrication. However, as we shift towards more sustainable practices in wind energy, there is also growing interest in using reinforced concrete for turbine towers. Concrete is less energy intensive to produce than steel, and it offers improved durability in certain environments. Researchers are looking into whether green cement or green steel can be made to further lower the carbon footprint of both these materials. As we've discussed, each part of a wind turbine requires materials with specific characteristics such as strength, weight, and durability. With the growing demand for wind energy and the push for a circular economy, manufacturers are increasingly focused on using and designing with materials that are recyclable, sustainable, and can fulfill the requirements needed from these materials. Now, let's talk about the broader challenge of circularity. In a circular economy, the goal is to close the loop by ensuring that materials are maintained, reused, recycled, or upcycled rather than disposed of at the end of their life cycle. This is a significant challenge for wind turbines, especially given the materials currently used. A few examples we touched upon in this video are the composites that are not easily recyclable, the rare earth metals used in the permanent magnets, and steel versus concrete towers. The large-scale and complex design of wind turbines make it difficult to efficiently close the loop for the different components. As we look forward, the wind energy sector must continue to innovate and explore new materials and methods to make turbines more sustainable and circular. Advances in, for instance, composite materials, recycling techniques, and design strategies will play a crucial role in reducing the environmental impact of wind turbines, while maintaining their efficiency and performance. Thank you for joining me in this deeper look into the materials that make up wind turbines. I hope you have gained a better understanding of why certain materials are chosen, the challenges associated with them, and the ongoing efforts to make wind energy more sustainable and circular.